This being the easy way. This plate being okay, we're going for the easy way. And this right here is just a piece of, that's a piece of 1/2 inch plate. And it's, if you measured it back this way right here, that's 7 3/4 inches long. And this up this way over here is 9 1/2 across yonder. And you can see what I did right there. I measured over yonder halfway on both sides, like that. And I put a punch mark, and then I come over here, and I put it over here like that right there, and it's right in the center of that piece of metal. Okay, I don't have to measure that no more. We know where the center is. These blocks are this size. That seems to work in my dimensions. So this 1/2 inch block being square in all manner, it's been used for something else. Snipped off on the corner, a hole and some holes here, but it's square. So, and these are square. So what I'm going to do, I'll show it to you, is the only thing we're concerned with right now is getting this block square with this piece of metal down here. Okay, if I look at the shadow line across through yonder and the shadow line across right up through here, I can tell if that's square or if it is not square. To the point of getting this instrument out and putting on here and coming back like that right there, the distance of error that this will produce is more than the distance of your eyesight if you can see good. So, see, I'm confident that that line right there is perfectly straight right now. Well, it turns out to be, if that line's straight there and it's straight yonder, it'll be straight across yonder, which it is. I should get the camera up here and show you that. It's unbelievable. But that's the measurement we're going for. Okay, and I clamped it, and it is square. So now the next piece, the only thing we're concerned about is getting this square with this piece of metal. And you do the same thing, line it up down yonder, and you line it up on the back. So you say, well, the corner was going off that piece of metal. It's irrelevant in this measurement because we know how square, how it is this way and this way and this way here. Now, only thing we're trying to achieve now is the squareness of this thing in relationship to that piece of metal, going by the shadow line down here. Okay. Okay, and at this point, you want to have this angle block in perfect relationship to this angle block by using the piece of metal as the square. So now my shadow line on this right here is about the thickness of a thumbnail. You have to have something for reference. If that goes away, then you're totally out of square. So I have that, and over here I do And over here too. Well, see, if you fast forwarded through them few seconds right there when I was adjusting the tension on this vice grip, if you fast forwarded that, then you would have not got the point that I was making there as to sneaking up onto how much grip you have on this gauge block. Enough to overcome the leverage and secure it permanently, being able to remove it later. So now we got them two blocks right there. That's pretty good. So not to be fooling around, we'll bring this into play now. I'll probably should measure that up for you. So this was a bar of something. It was a big old clamp when I got that. It's nice metal, but it's come to be of great use to me. It's 1.5 tall, and it's 1 inch thick that way. 1.5 by 1. And it's as long as it is, just to cut off. But it's square and level, and it's a nice measurement if you need something to come out within the center of this this right here. Let's back up and put that in there, and you'll get a better view of that part. This being the top turn plate, and this being the pivot, cut from the same piece of metal. They're 4 inches. So what you do is you bolt this together. So now we have established a center line on our top plate. This top plate being 12 inches from here to here. If you put the measurement on it, it's 12 inches across through there. This top piece right here being 4 inches. 1/4 inch thick. 10/18 steel, just, you know, flat stock. But the way you position that part easily and precisely is, we know this piece of metal, the dimensions of it is square to the center point we marked on it earlier. So we know it's all in proportion. In order to get this thing equaled up across through yonder, we just have to measure from here to here and here to here. Looking at it from eyesight, it should be about right there. And I'm going by how much eclipse I have on those holes right there, and visually aligning that. But we probably should confirm that measurement. I'll show you. You put the little slider up there against the end of that metal, and then push the thing in there until you have a measurement which is the edge of this and the edge of that in comparison to each other that's you are okay with. So then the next measurement is you come over on this other side over here and you measure the same measurement. Well, that's pretty good. I should get the camera over here on that. Now we got that top plate up there, this thing right here, where it's going to be welded in there at. So in order to secure that and not be a losing there measurement, clamp that on like that, and clamp that on there too. Now, supposedly, we have positioned that in alignment, both pieces at once in relationship to the whole squareness of everything. So to confirm it didn't move when we clamped it down there, come back over here, we get your measure, put down there, and let it touch that. So I'm gonna go with that. And then you come over here and you do it on this side right here, and I'm gonna go with that. Let's see if it moved in it. Oh no. So that's where that's gonna be. The easy way now is to bring this, it's 1.5 tall and 1 inch that way. And just loosely, we'll put it up there towards the front of the piece of metal, loosely in the center. Now, when I was cutting that bar up, I cut some more blocks that will go there, and over here I had a couple of shorter ones, which all we're doing here is establishing a plane as to comparison to the center line of this 2 inches right here. 1.5 inches, and you're using 1 inch material, you have a 1/2 inch here and then the other half on the other side being 1 inch. So it gives you a center line by 1.5 inches. So, and it's not complicated at all if you kind of just study on it for a bit. The center line of the wheel, in the case right here, I'm using an 1/8 inch cast iron flat faced wheel, roller bearing. So 4 inches is made us halfway on that, so wherever your axle is, this being the axle, and wherever this being in relationship to the top up there, in order for your cart to turn underneath the cart, then it has to be half of whatever size of wheel you're using. Like a 10-inch wheel, you'd have a 5-inch measurement here, and taking in consideration a 1/2 inch on this 1 inch round bar, and taking in consideration an extra 1/4 inch spacer here in order to align this bracket up on the rear bolster, and then the cart would come out the same height. Then you use the same measurements, except these two parts are 1/4 inch longer on the rear one because they mount onto that up there, and then this and down here it mounts onto this and down here. So, and in this case here with the 8-inch wheels, it comes out to be 4 inches between this top plate and the top of this. So what I did is I cut a couple of spacers, one each square block solid, and I can put one in there. I have two of those, and they're flat to each other. Now that I've established with those two spacers right there, how far from the top here down to the center line on the axle is, and then that is that being determined by how big the wheels is. So, and you can see on this axle, this will be an 18 inches from 1 inch to 1 inch, and then two wheels will be on the outboard of this. And I've established a center line with a punch mark right there. So at this point, we don't need to measure this no more in its individually. So we'll put this up here. Now, when I laid that down right there, did you see that I established that 4-inch gap in there already? So you say, well, what about the axle? Can it be over here or can it be over here? Which it can be. So we have to center that up in relationship to the center of this back plate, and that being the center line of your cart. But if you remember, before we ever started, we established that punch mark down here to center everything up to this point. So now, with this axle tube, then we just have to position it on there and push back on it to where it's got the 4 inches there, and then move it over to where, you can look at it and get it on. You can look at it and get it all correct. And so to do that, we got a punch mark here, and everything's square and level and true and plumb to itself. Then we put the square on there, slide it over, and this top okay, I missed it by a little bit. Okay, we'll look at it. Okay, can we see that? See, that's good enough to weld right there. So now we've got that. We've got our axle in a position to where that we want that axle to be when it's all over with. It's okay. I clamped that down right there, but I'm gonna have to move it. Okay. The reason I had to move it over a little bit is I clamped it on the center line, and I need to bend it over a little bit so I can put this on here and then come back over and verify that it didn't move when I clamped it down. So now, just with the vice grips and that right there, and this right here, and this right here, we've established the center line of this axle and this top bolster plate here. We've already established that a wheel will turn in this amount. Now, probably should be looking straight down on it, but we ain't, so I'll tell you about it. This thing right here, this is cut at an angle from this bottom of that top plate right there down to the top of the axle. It's cut at an angle where that it matches. If you just put it in there like that, then you're at 4 inches and it's fitted right here. Okay, if say I was using a 10, 12, 14, or 16 inch wheel on here, then this distance from here to here would change, and so would the angle on the end of this right here. You just put your piece of metal up there and and mark, that's your angle there, and that's your angle down there, and you saw it at that angle, and then just put it in there, and that way you'll have this type rather than a straight up and down. You know, I'm just saying, could be round stock or whatever, but that's the principle of it. So at this point, you just slide these two 4-inch alignment blocks out of there. And now we've got the axle and the top plate. Now we have to get them uprights in there. So I'm gonna move them over there where we kind of get a little bit of support on them. And that's just height measured, height blocks. And these right here, all this right here had that, it came like this right here, mill slag on it. So if you take that's a 36 grit right there, I think, on a grinder, and shine it up, then it's a lot easier to have clean metal to paint once you get it welded together than working with this mill scale on your. So I done took it all off of these. And it's 11 gauge, this material is, which is about 1/8 of an inch. It's pretty strong to tip you off. And it's normal welding procedures at this point is, you know, you grind the angle right there, the length of that, the length of that. That way when you put down in there and up there like that, when you put that in there like that, yeah, when you put in there like that, and line up on that bottom block down there like that right there. See, so you got good angle in there, and you've got a valley right there because this tubing is rounded over, corners are, so that gives you a real nice weld that's really strong. So, once you get this all measured up there like that, then you bring these things in, and I done ground them at that's about a 45 degrees right there. It's really good, really strong weld. And the way to line these up where you don't have to get a lot of measuring apparatuses out is this edge right here. If you just use the 4-inch wide or whatever your width is, if it's cut pretty close to accurate, then that's good enough for measurement, because you want some kind of like a step right there to weld to, you know, whatever length you decide to weld right there, then it's where you position this. Okay, so what I'm going to do, that right there is where I want that to kind of be. Okay, see, I just held that in there with some bias to flatness, and then I lined it up on the edge of that. This 4-inch plate there is my measurement. So now it's the other one. So I want the other one to match that one on the top plate up there. So okay, about right there is where I think it should be. Okay. Now, you know, we're pretty much good enough. We're ready to weld right now. But to check ourselves, we need to know the measurement here, here, and here. So in order to confirm everything before we weld it, we take a square and put it on the bottom axle down here, and slide it over to where that's the measurement of this. Now we want to measure from the inside of that over to that top plate right there, and it's 3 inches and a little bit. So you come over here and do the same thing. And it's 3 inches and a little bit. So now we know by measurement, mathematics, that it's squared this way, and our square is square here, and we're square there, and that's 4 inches, and it's the same amount there and there. So now, to know if we're going to look good down here, you can measure from the outside here up to the tip on that thing right there, and so you put up against that, and then you lock that in. So that's how long that is, and then you come on the other side and compare it. So see, this one's a little shorter, so it should come this way. Okay. Okay, I'm gonna go with the shorter one. Okay, this is the shorter one of the two, so I'm gonna come over here and that's good enough to weld. I don't have to. It's good. So let's weld that up.